Hello there, and welcome to a brand new video. This is Happy Beyond Numbers, where we learn the easy way. I do hope you are doing well and you have been able to go through all that we've done so far. In this video, we are looking at the construction of locus. You've been hearing of the word locus, locus, locus. What is it? We'll be constructing the basic or the most popular locus we know around for our level. First of all, what is a locus? So when we talk of a locus of a point is the path the point traces as it moves, obeying certain conditions. You see, so if you take a point and then it is moving whilst obeying certain conditions, we say it is what a locus. What are some of the locuses, or in plural term, we call it loci, right? Loci. What are the examples we know? We know the first one being a circle. So a circle is what? The fixed distance from a point. You see, so the type of a locus that describes a fixed distance from a point is called a circle. And we use the compass to draw the circle around that point. Now, when we talk of a locus that is equidistant from 2 points, then we call that one the perpendicular bisector. The locus of what? A locus that is equidistant from 2 fixed points. We call it a perpendicular bisector. Then a locus that has a fixed distance from a line. The third one here. A locus that has a fixed distance from a line, we call that parallel lines, right? So those are two parallel lines. Then locus that is equidistant from two intersecting lines. That is an angle bisector. We'll be constructing all of these, and I do hope you would get to know why and then how to construct all of these. Then equidistant from two parallel lines is what? A midline, right? So now that we've seen the various loci available, let's look at how we can construct them as well. Okay, so the first locus we'll be constructing that of a circle, right? Then we say the circle is a locus of a point equidistant from a fixed point, right? A circle is a locus of a point equidistant from a fixed point. So that simply means we are definitely going to have a fixed point somewhere, right? So we can say this is our fixed point, right? So this here is my fixed point. Now the question says we have to construct the locus of point 4 centimeters from point C. So if this here is our point C, we want the locus of point 4 centimeters away from this. All the points that are 4 centimeters away from it. And since it is a point and then the distance is 4 centimeters, we just take our compass. You open to a distance of 4 centimeters. So as you can see me do here, I'm opening to 4 centimeters. So with my 4 centimeters, I now bring it to the point of reference. And what do? I draw my circle, right? And I can now take off my compass. So all these are what? 4 centimeters away from this point. If you measure from here to here, it's 4 centimeters. Here to here is 4 centimeters. All the distance away from the point is what? 4 centimeters. So I mean, from here to here is 4 centimeters. From the point to any point at all is what? 4 centimeters. That is what we are saying is the locus of points equidistant from a fixed point, being a circle. So that is that. Now let's look at another locus construction. Okay, so now the second locus we'll be looking at is the locus of a point equidistant from two fixed points. The locus of a point equidistant from two fixed points, and that is a perpendicular bisector. A perpendicular bisector. Remember, a locus equidistant from one fixed point is a circle, but two fixed points is a perpendicular bisector. So this question here says, You have to draw the locus of a point equidistant from AB, where AB is 6 centimeters. So first of all, I'm going to get my point AB. So let me use my ruler and then draw a 6 centimeter line. So starting from my 0 here, I move all the way to my 6, right? So this is my 6 centimeter line. So I'm naming here my A. This is my A. And this here is going to be my B. So we want a point that if you measure from A to B, sorry, if you measure from A to that point, it will be the same as measuring from B to that point. You see? Then we say we call it a perpendicular bisector. So let's look at how we construct this perpendicular bisector. Of course, we've constructed most of these perpendiculars in our previous examples, right? So all you need to do to construct a perpendicular bisector, which is a locus equidistant from two fixed points, is you stand at one end of your line, right? Or the initial point you want to construct the perpendicular bisector. Then open your compass. You make sure it is approximately more than half of the distance between A and then B. I draw an arc here and then I draw another arc over here. With the same radius, you take your compass and stand at the other end. You see, that is at B. And then draw an arc, making sure it cuts the initial one you drew, right? And as usual, I'll just clean my excess that I don't really need to make my work look nicer. Then after this, you now draw a straight line through these points of intersections. So you take your ruler and you draw a straight line, all right? So a straight line from this point straight towards this point. That is it. So after drawing your line, what do? You can choose to measure and see if it is really equidistant. So I'll be measuring mine over here with my ruler. Now, as you can see, I have 0 in the middle here. If you have to measure from A to the middle, it is what? 3 centimeters. And if you also to measure from the middle to B, it is also 3 centimeters. Hence, I've gotten the locus of points equidistant from A and B, where A and B is what? 6 centimeters. And as I have said earlier on, locus of two fixed points is a perpendicular bisector. Now let's look at the locus equidistant from a straight line, right? So you have a line and you want all the set of points that are equidistant from that straight line. So let's look at how to do that. So to get this locus we are talking about, that is two parallel lines. Let's look at this as an example. It says we should draw a locus of 0.2 centimeters from a line. A locus of 0.2 centimeters from a line. And the line is what? 8 centimeters long. So let me just draw an 8 centimeter line over here. An 8 centimeter line. So I'm going to start from here and end over here. That is an 8 centimeter line. And we can even measure to confirm that. So this is my 8 centimeter line over here, right? Okay. So if this is my 8 centimeter line over here, we want all the set of points that are 2 centimeters away from this line. You see? So to do that, what you do is you need your compass. You need your compass and you make sure you open 2 centimeters on your ruler. You see? So this is my 2 centimeter here, as you can see. So I'll bring it on any point, right? You can use any number of points, but you make sure it's just evenly spaced, right? Then You draw an arc above and then draw an arc below. You see, you take your compass, you can bring it to the end over here, and then draw an arc above and then another arc below. You take your compass, bring it to the middle, draw an arc above and then another arc below. We want to draw parallel lines, you see. So that is what we do. You can also bring it here as well. To enhance your accuracy, you can do it a number of times, but at least 3 is fine, you see, depending on the length of the line you are drawing. But at least 3 is fine. Where the 3, you have one at the two at the extremes and then one at the what middle. So these are the lines I have these are the arcs I have drawn. Then what I do is I make sure I draw a straight line that what touches the tip of all these arcs. You see? So you take your ruler and you draw a straight line. So I'm just going to use and I draw a very straight line. This is my straight line here. And I do same down here as well. You see? You are going to use your ruler to draw that. You make sure it is at the tip of these arcs you've drawn. And that is just it. It means this ruler here, this line here, and then this line here, they are what? The locus of this line. And they are all exactly 2 centimeters away from this line. You can always use your ruler to measure that just to confirm. So as you can see, if I start from here, even from here, these 2 lines are 2 centimeters away. You can see that also over here. And so can you see over here, they are all 2 centimeters away. Now, since we are on this, let me just quickly chip this in. So assuming you had these lines rather, I'm going to delete this arcs that I have drawn. And then assuming we have these 2 parallel lines, I mean, this one over here, this and then this. And you want their locus. You see, so you want the locus of 2 parallel lines. So initially, this was what we did here. This one. So equidistant from 2 parallel lines. It is called a midline. A midline. You see. So if we take these 2 parallel lines, 1, 2, you see, and we want their locus. This here is what we call the midline. Right? So the locus of a line and then the locus of 2 parallel lines, they work hand in hand. The locus of a line is 2 parallel lines, one above, one below. But then the locus of 2 parallel lines is a midline. You see? So that then brings us to the very last one, which is the locus of a point equidistant from 2 intersecting straight lines. So equidistant from 2 intersecting lines. And we call that an angle bisector. An angle bisector. So let's look at how we can construct this angle bisector. And as a matter of fact, we've actually done that in most of our sessions already. Okay, so for this straight one, which is the locus of point equidistant from 2 intersecting straight lines, let's look at this question. We have to construct the locus of point equidistant from line L. So this is line L, and then M. This here is our line M, where M is a line intersecting L at 50 degrees. So these are 50 degrees. At point B, so this point here is our B. Now we want to construct the locus, that is the equidistance from this line and then this line. You see? So to get the locus of these type of figures, we just have to bisect the angle. You see? So let me just bisect this angle or this angle. Then we'll see what we are talking about over here. And in our previous lessons as well, we have looked at how to bisect angles, haven't we? And to bisect an angle, we just first of all take our compass and then draw an arc. So I'll draw an arc over here nicely. And the point of this arc would guide me to get my what? 2 bisectors or my 2 arcs. So I would come and stand at the end of this arc that touches line L and open my radius, my compass to a suitable radius, and then draw an arc, one above. And I now come and stand also over here, open my compass at a suitable radius, no, with the same radius as the previous one. Then you draw an arc over here. Then with that, you are done. So you draw a straight line from point B, that is the point of intersection of the 2 lines, through the point of intersection of these 2 arcs. And you use your ruler for that. You see, now this here, the line you have drawn, this line is what we call your locus. All right, that line there is your locus. This over here. Yes. So basically, that is that. We have looked at what all these basic loci, right? In our next example, we'll be looking at how to construct a circumscribed circle, which is also one locus. A locus of, I think, a locus touching 3 points, right? And then we'll be looking also at an inscribed circle, that is a locus that touches 3 lines. So see you in our next video, and then I do hope this one helps. Stay blessed.